Hi, I'm Renee Clark. I'm from the University of Pittsburgh, Swanson School of Engineering, and I'm a faculty member in our Industrial Engineering department, and I'm going to talk to you today about engineering judgment. Let's define it, and let's talk about using it. And this presentation is based on research that I'm doing on defining and assessing engineering judgment, which is based on a grant that my colleague, Dr. Sam Dickerson, and I received from the National Science Foundation to do this. Dr. Dickerson is a professor of electrical and computer engineering. So I'd like to start my talk today by posing a question to you. So I'd like to ask you, is engineering judgment important in professional practice? What do you think? I think most people would agree, yes, it is, that it is an important competency, that it's critical to tasks that we as engineers do quite frequently, such as designing products and services, solving difficult problems, doing various analyses such as data analysis. Judgment, I would say, is definitely a uniquely human capability. Okay, okay, so now I want to pose a second question to you, which might be a little bit more difficult to answer. This question is, how would you define engineering judgment? If you're doing a little bit of a head scratcher, that's not unusual when I pose this question to people, often people who have been engineers for many years. I did the same thing when I asked myself the same question several years ago. Engineering judgment, certainly as a definition, tends to be a little bit elusive, yes? There are actually many concepts or notions of it in the literature. But to this point, there's been no agreed upon consensus sort of formal definition for engineering judgment that attempts to synthesize or integrate the various notions or concepts of engineering judgment that you would find in the literature. Okay? And this poses a little bit of an issue because without a definition, the question becomes, how do we assess students, for example, for the presence of engineering judgment? What types of educational materials do we provide on it? What types of education should we provide on engineering judgment? Okay, and we know engineering judgment intuitively is important. So besides that fact, ABET, our accrediting body, actually tells us that it's an expected outcome of students upon graduation. Okay, specifically, ABET Outcome 4 says that upon graduation, a student should possess an ability to make informed judgments. Okay, and in another of the ABET outcomes, there's 7 of them, ABET Outcome 6 says that a graduate should exhibit an ability to use engineering judgment, for example, to draw conclusions. Okay, so there's actually a bit of a gap between the needs and the expectations relative to engineering judgment or providing education on engineering judgment and the resources that are available to us at this point to provide good education on engineering judgment. Okay, so I'm going to pose this same question again to you. Okay, how do you define engineering judgment? Okay, so I'd like you to take just a few seconds and jot down on a piece of paper what you think engineering judgment is. How would you define it? What ideas come to your mind when you hear the words engineering judgment? Okay, so if you could just take a few minutes and do that. So on a little piece of paper, just jot down. These are my ideas of engineering judgment. We're going to come back to these and I'm going to tell you about some of the notions that are in the literature, and I'm going to show you a preliminary model or definition that we've been able to come up with, and it'll be interesting to see what notions that you may have written down coincide with what the literature is saying and the model that we've been actually able to come up with. So go ahead and jot those ideas down, because it'll be interesting to see the degree to which yours agree. And I'm going to guess that there's going to be some good agreement. Okay. All right. So after Dr. Dickerson and I realized this true gap several years ago, we went ahead and applied for some National Science Foundation funding to begin to explore the area of engineering judgment and perhaps coming up with a definition of it and ways to assess and provide education on it. Okay, so we were able to actually secure a grant from the NSF, and it's a grant from a program called Research in the Formation of Engineers. Okay, and it's an engineering education program. Engineering education program it's offered by the NSF. Okay, and it has a couple of our project has a couple of main goals. The first is to come up with a consensus-based definition for engineering judgment, which we began to work on last fall, fall of 2024, and we came up with something, and we've been out showing the definition to different people and trying to get, trying to vet it and do some validation with it. Once we had a preliminary definition in the fall, that's when we could begin to take it into our classrooms. And Dr. Dickerson and I took it into each of our classrooms. He teaches a junior design course in electrical and computer engineering, and I teach statistics in industrial engineering. Okay, so in the spring of 25, we began to develop some educational and assessment materials based on our preliminary definition that we had come up with in the fall, and we took it into our classrooms. Okay, so how did we come up with the consensus definition, though, in the fall before we took it into our classrooms? Okay, we used a method known as the Delphi method, okay, which is a method that's used to drive consensus among a group of people. Okay, we actually had 18 people on our panel that helped us to do this, and they were professionals from both academia or from universities, as well as industry, so practicing engineers, okay? And we asked these people about their notions of engineering judgment using the concepts that we had uncovered from the literature, okay? And we actually handpicked these 18 panel members. And one of the ways that I handpicked them was that some of them had actually contributed to some of the literature that's out there on engineering judgment and that covers these many concepts or notions of it. Okay, so when we went into the literature to search for these various concepts of engineering judgment, we came up with 14 main notions of engineering judgment in the literature that we used to inform our Delphi study. Okay, so these are the 14 items we found, and as I go down through them, ask yourself, ooh, did I put this down on my piece of paper or on my card? Okay, so this is what the literature, the concepts of engineering judgment in the literature. The first is application of one's knowledge or experience. Engineering judgment is approximation. It's asking, is something reasonable? It's consideration of various contexts, such as societal contexts, ethical contexts, or cultural contexts, etc., when you are, for example, designing something or solving a problem. There's a notion of it in the literature of creativity, critical thinking, decision making, including weighing of issues. So, decision making in the midst of complexity. It's being able to identify important versus non-important details, including defining the right problem. It's being able to foresee potential problems. It's making assumptions when necessary, for example, to simplify a problem or to be able to solve a problem. Okay. It's being able to recognize mistakes or errors in one's work, including through testing. It's being able to use feedback, constructive feedback, use and apply it. It's making use of tools or standards or codes of practice. And the 14th notion of it in the literature is that of it involves effective communication. Okay, so that's what that's what's out there in the literature. Okay, so first question is, are any of these on your piece of paper or on your card? If so, great. And so this was the work of our Delphi panel, is to somehow try to take all these various concepts or notions and integrate them, come up with a definition that involves all of them. Okay, so on our Delphi panel, the 18 people that we had, they represented a wide range of disciplines, okay, so that we made sure to get we made sure to get diverse perspectives, right? Because engineering is a very broad area, okay? So on our panel, we had people from the following engineering disciplines. We had aerospace engineers, bioengineers, chemical engineers, civil, environmental, geotechnical, software engineers, electrical engineers, and mechanical engineers, okay? We also had some people on our panel who were not expressly engineers. Actually, we handpicked these people because they were some of the people that had contributed to that literature that I told you about. So we actually had people on the panel who were from secondary education, who specialized in English, who specialized in just engineering ed research, and we also had one person who focused on risk and safety. And in addition, we had 3 ABET evaluators on the panel because of the involvement of, or the association of engineering judgment with ABET in terms of it being a required outcome upon graduation. Okay, so what did the Delphi panel come up with in terms of a consensus definition for engineering judgment? Okay, so how did the panel define engineering judgment? Okay, at its core, what the panel found, or the Delphi study found, was that engineering judgment is actually a very simple process. Okay, it's composed of 3 main components. Okay, the first one is you, right, the engineer or professional. The second main component is the situational context, and what we mean by that is the factors or the conditions that might surround a given problem that you're trying to solve, or design that you're trying to make, or analysis that you're trying to do, okay? And the third main element is critical thinking, okay? Okay, so this is a very abstracted visual model of the definition of engineering judgment that the panel was able to come up with. So it's very abstracted at this point, okay? So what this model is saying is that, first, engineering judgment is a process that's initiated by some sort of opportunity or problem that you're trying to solve. Think of an opportunity as some sort of a design need, okay? So the process is driven, the engineering judgment process is driven by something that you need to solve, or something that you need to do that's perhaps rather somewhat complex, okay? Now, the boxes that are contained within the light blue boxed area here, those are the components that actually comprise the engineering judgment process, okay? And there are those 3 main components that I told you about, right? You, the engineer professional, the situational context, and there's the critical thinking, okay? So the way to read this is the following, okay? The engineer or the professional applies or incorporates certain knowledge or traits or features in an ongoing way to perform critical thinking, while at the same time considering various situational context factors or issues also to perform critical thinking. So those hatched arrows mean that you are, as the engineer, you're continuously applying or incorporating or continuously considering different situational context factors as you're performing critical thinking, okay? Now, a large component or a subcomponent of critical thinking is evaluation, okay? Now, what I also want you to notice is this thick blue arrow that goes from critical thinking back to the engineer professional, okay? So what we think is going on as part of the engineering judgment process is that there's a learning loop as well, a formative loop that says that as you, as the engineer, performs critical thinking and, and the results of that critical thinking undergo evaluation, you are at the same time learning, okay? You are building on your knowledge and your experience, and there's a formative impact that's occurring, okay? So, the output of all of that at the end is some sort of a culminating decision or solution that results or that is made out of the engineering judgment process, right? Now, we believe judgment develops over years, right? And this is, in part depicted by that feedback arrow, right? Um, Certainly as a undergraduate, you will begin to learn engineering judgment and you will begin to exercise engineering judgment, but it's really something that develops over years, okay? And again, as is captured in that feedback loop. Okay, so that's our fairly simple or abstracted process of what engineering judgment is. When you actually go to apply it in the real world, it actually becomes a lot more complex, detailed process that we think looks like this. Okay, so this is a more, what should say, fleshed out definition or model, a less abstract version of what I just showed you, but it still has all the main components. It just has more detail, right? It still has the driving opportunity or problem. It still has the culminating or final decision or solution that comes out of your engineering judgment deliberations, okay? Still has the engineer or a professional as one of the main components. There's the situational context. Here's the critical thinking with the evaluation as being a major subcomponent of that. Here's the arrow that shows you're going to apply certain features as an engineer or consider parts of the situational context. And then there's that formative impact learning loop. Okay, so it's all there. This model just shows a lot more detail, right? Because when you go to apply it in the real world, things are more complex, right? So I know this is overwhelming to look at it first, but I'm actually going to step you through each of those main components and then for example, the yellow boxes that you see or the subcomponents of the engineer professional, and then we'll bring it all back together. Okay, so before I do that, what is my goal with this model? What are our goals with this model? Okay, at this point, we mean this to show this model as an educational resource for instructors and others, even for people in industry, right? We mean it as a practice guide for people that they can use it, for example, as they work on their project work. So as you work on your projects as students, would like you to, for example, reference this model as a practice guide. Now, as you work on different projects, not all of the sub boxes may apply, right? You saw a lot of those yellow boxes. They may not all apply, as you'll see, to any given project. So again, this is a guide. Okay, we'd like you to use it as appropriate in your projects. Okay, and one other sort of a caveat is that model is still preliminary. We've been doing a lot of vetting of it and a lot of validation, and it's shown certainly face validity and robustness with people, but it's still in its preliminary stage. Okay, so let's walk through more of the detail. Let's start with the situational context and what that looks like at the more detailed level. Okay, so the situational context, remember, are the factors, the issues that surround a problem or a design opportunity, okay? So these are the 10 factors that we've been able to come up with thus far that comprise the situational context that an engineer should be considering when they're doing critical thinking, right? We have, just for organizational purposes, kind of roughly grouped them into people factors or factors that are sort of more specific to people, versus factors that may be more specific to a product or a process. Okay, so what are some of these situational context factors that may be more related to people? Okay, so certainly when you are designing something or solving a problem, there are societal or social factors that you should be taking into consideration, right? There are cultural or global factors. Okay, there are ethical factors, right? There may be health and safety factors. There may be aesthetic factors, okay, so over into the product process factors. Now, again, not all of these may apply to any given problem, but given what you're doing at the time, aesthetic factors may play in. For example, if you're designing a car, right? Certainly aesthetic factors play a role. There may be economic factors you have to take into consideration, environmental factors, right? Okay. Uncertainty may play a role, taking into consideration or into account what you don't know, right, or unknowns that exist, including risk. Constraints always play a role with engineering judgment. Cost constraints, right, time constraints, other resources, regulations certainly play a role. Things such as Federal Communications Regulations or FAA regulations. Okay, and then the final situational context factor is complexity, right? Being able to consider the complexity of your problem or what you're trying to design. Okay, and complexity is driven by when you've got competing issues or trade-offs that you have to weigh, right? Or the fact that a lot of variables and factors are interdependent. So when you impact one, you impact the other. Okay? Even just the dynamics or the politics of an organization that you may be working in, okay, contributes to the complexity of, the problem you may be trying to solve or the design you may be trying to accomplish. Okay? So, just to talk about the situational context a little bit more, these are some examples from Dr. Dickerson's junior design class, which is a class for electrical and computer engineering juniors at the University of Pittsburgh. And these were some examples of various situational context factors that he talked to his students about when he gave this presentation to them. So remember that these are ECE students. So these examples would be a little bit more specific to electrical and computer engineering projects. But for example, there are FCC regulations, right? Federal communications regulations, for example, when you are designing wireless devices, okay? They represent a constraint, right? That you have to work with, that you have to consider as part of a design, okay? As an example of a cultural factor may be if you're a software engineer and you're designing a video game, you may need to adapt that video game or the storyline within that video game to various norms or interests of the country in which you're going to be marketing that video game, right? How about when you're designing a user interface? You do need to absolutely design with your audience in mind, with your people in mind, okay? So you might consider that a societal factor, okay? An environmental factor. Electronic waste is a large global problem, right? Old iPads, old phones. What do you do with these? So perhaps when you are designing the next generation, you might want to consider minimizing. How can I go about minimizing future electronic waste, right? Aesthetic factors, as I said, if you're designing a car or perhaps a toy for a child, certainly it has to look good, right? You have to consider aesthetics. And finally, a good health and safety factor, good health and safety example would be that of trying to consider, should I use lead versus non-lead based solder? So there are health and safety concerns with lead, but there are benefits to and drawbacks to each of these. So it's a consideration that you have to take into account if you need to use the soldering process. Okay, so let's flesh out then, we just talked about the situational context. Let's flesh out a little bit more the traits and the features that you as the engineer or the professional bring to the engineering judgment process. Okay, so what do you bring? Well, actually, you bring a lot. These are the things you bring and that you should apply or incorporate as part of the engineering judgment process. Okay, so first of all, you bring a lot of explicit knowledge. So what do we mean by explicit knowledge? Okay, we mean knowledge that's documented, right? So things that you may be learning in your coursework, right? Academic knowledge. Data that you may collect or have access to. Various forms of media that you may read or access. Standards and codes. Okay, so for example, IEEE, which is the Institute for Electronic and Electrical Engineers, has, for example, Code 754, which discusses floating point division. Okay, so various standards and codes that we have to be aware of and use as engineers. Perhaps various skill sets that you bring, how to program a computer, how to use computer-aided design, how to use simulation software, certain skill sets. Okay, so those types of things represent your explicit knowledge, knowledge that tends to be documented. Okay, so knowledge that tends to be less documented or perhaps even less documentable is what we refer to as tacit knowledge. Okay, this is knowledge that, for example, tends to be based on experience, right? Or intuition that you might have, often which is driven by experience, right? And that, kind of just this facet in and of itself gets at, why we think engineering judgment develops over time, right? You have to build your experience as an engineer in order for your engineering judgment to really grow and get really sharp. Okay, so what else do you as an engineer bring? Well, you bring what's known as metacognition. I don't know if you've ever heard this term before, but what metacognition is, meta means sitting above. Okay, so metacognition is just thinking about your own thinking or your own behavior. Okay, and so when you think about your own thinking or your own behavior, you tend to drive a lot of self-awareness, right? And so you do this by reflecting, right? Doing a lot of reflecting. Metacognition also involves what's known as self-regulation. What do we mean by self-regulation? That essentially means your ability to manage yourself, manage your behavior, manage your learning, right? Things such as your ability to plan things, plan for your learning, the ability to monitor yourself, monitor your progress, monitor your work. Am I doing well? Am I doing what I need to be doing? And then the final part of self-regulation is evaluating oneself after the fact, right? Okay, so metacognition tends to be a behavioral-based trait or quality that you as the engineer bring to the engineering judgment process or should bring to that process, okay? And then finally, you bring your identity to the engineering judgment process, right? So initially, you might say, what in the world does my identity have to do with engineering judgment? Okay, and a lot of people say that at first, but this notion tends to grow on you. What we mean here by your identity are things like your values, your character, your morals. These most certainly play into the engineering judgment process. Your interests, your self-efficacy. Do you know what we mean by self-efficacy? What we mean by that is your belief in your ability to be successful at something. So it has to do a lot with your self-confidence, okay? So those are the aspects of your identity that we believe are most important to the engineering judgment process. Okay, so these are the four main things that you as a professional or engineer bring to the process. Your explicit knowledge, your tacit knowledge, your metacognition, meaning your self-awareness, your behavior in terms of being able to plan, monitor yourself, self-evaluate, and your identity, okay? These are all incorporated or applied in the process as part of the critical thinking. Okay, so we covered that. We just covered that. Let's talk about what is involved in critical thinking. Okay, this is what we believe comprises the critical thinking process. Okay, remember, critical thinking has a big subcomponent to it, evaluation. That sits over there. Okay, so this is what we think critical thinking is, or what should be done during critical thinking as part of the engineering judgment process. Okay, first, you have to define the problem or goal that you're trying to accomplish or that you're trying to solve, right? Defining that right problem. What is it that I really need to do? Okay, and that's not easy to whittle that down as to what you at times really need to do. Okay, now once you do that, you can begin to identify solutions. All right, which may involve various modeling techniques. Maybe you are going to simulate your solution. You're going to prototype it. Certainly as part of that, at times you have to approximate various things to get to a solution. You may need to make some assumptions. Okay. Once you identify various solutions, you make a decision on the one you want to go with. Right. Now, it doesn't just stop there, right? These 3 steps should always be evaluated, and it actually should be somewhat of an iterative back and forth process. So, as you begin to define the problem, identify solutions, and then perhaps make a decision, you should be evaluating each and every one of those, okay? Meaning you should be doing testing, okay? You should be critiquing your work, looking for errors, actively looking for errors. You should be trying to foresee problems. Okay, look into how a solution may impact something down the line. Okay, and certainly as part of the evaluation, you should be seeking feedback from others. You should be communicating with others about what you're doing. Okay, so it should be an iterative back and forth of these steps being evaluated. Okay, that's what we think is involved in the critical thinking process. Okay, so bringing it all back together then, okay, we think that the engineering judgment process is driven by an opportunity or problem. It results in some sort of a culminating decision or solution that you're able to come up with, which itself is subject to evaluation, right? But you bring knowledge, experience, good behaviors through your metacognition. You bring certain identity factors. You apply those or incorporate those on an ongoing basis into the critical thinking box. You consider various situational context factors, such as the uncertainty surrounding what you're doing, the constraints surrounding what you're doing, the complexity of what you're working with, things such as social factors, safety factors, economic factors, environmental factors. That all gets considered in an ongoing basis to do this critical thinking, which should always be evaluated back and forth. Okay, but remember, good engineering judgment happens over time, right? I think our goal here is to begin to get you to think about what comprises good engineering judgment and to begin to develop those skills. And we want to begin to assess you in those skills. But really, engineering judgment develops over time. And as you exercise engineering judgment and as you evaluate what you're doing and you get feedback, there's going to be learning that's occurring over time. There's going to be a formative impact to you, and it's going to alter your knowledge. It's going to grow your knowledge, your explicit knowledge. It's going to grow your experience and your intuition. It's probably going to begin to, perhaps change some things about your professional identity, okay? And hopefully it will enhance your self-regulation, okay? So there's going to be a feedback loop. So I wanted to thank you today for listening to this talk and considering engineering judgment and and what we've been able to come up with it. I wanted to again acknowledge the National Science Foundation and thank them for their support of our work, and it was supported under Grant 234-8089. If you have questions about this or would like to otherwise talk to me, I am again Renee Clark from the University of Pittsburgh Swanson School of Engineering, and this is my email address, rmclark@pitt.edu. I would welcome any questions you have, and thank you for your time and attention to this.